Hi there. Well, I'm going to look at sections 3.4, 3.5, and 3.6 in this video. Now, before we get started, we're going to talk a little bit about fractions and what's called equivalent fractions. Fractions that may look different, but actually have the same, they represent the same amount. All right, so if you have these three examples here, and these circles are actually the same size, they look a little different. I think it's the document camera's angle. But this one right here, this green one, is divided into thirds because we have three equal parts. So we know we have thirds. The red one is divided into sixths because we have six equal parts. So here, this cream colored one is divided into 12 equal parts. So what we have, the number of equal parts is our denominator. So this one is sixth, and this one is twelfths. All right, so we have the 3, 6, and 12ths. Now let's look at this green one. Let's say that I have 1 out of the 3. We say that's 1/3, 1 out of the 3. Now, if I were to take this out here, and let's say I wanted this same amount, but with the red. How many of these reds would I need so that it equals 1/3? Well, this amount, I would need 2 of the sixths to represent. So this amount, I would need 2 of the sixths to represent 1/3. Those two are the same size. Well, what if I have twelfths? How many of these twelfths would I need to represent this right here? So if I were to lay this over, I would need 4 of those twelfths. 4 of those twelfths is the same as 1/3. So what we have here, because they represent the same amount, I'm going to take these 4 out. Because they represent the same amount, these are called equivalent fractions. Okay, equivalent fractions. I'm having a hard time getting it over that piece of paper. But, all right. So each of these represents 1/3. They're equivalent fractions, yet they look different. Also, notice that bottom number. As the bottom number gets larger, the pieces get smaller because this represents how many you're dividing your whole into. I'm taking the whole and I'm dividing it into 3 equal parts. But if I divide it into 6 equal parts, the parts need to be smaller because there's more of them. And here I'm dividing it into 12 equal parts. So each of these pieces needs to be even smaller. All right, so as the denominator gets larger, the pieces themselves get smaller because you're dividing it into more pieces. So they need to be smaller. But again, each of these are called equivalent fractions because they represent the same amount. Well, within these sections here, you're going to need to go from this fraction to this fraction. Or how do you go from 1/3 to 4/12? And then also you're going to have to go from 4/12 back to 1/3. To do that, to move from one to the other, it's going to take either multiplication or division, is how we move from one equivalent fraction to the next equivalent fraction. So what I'm going to do is I'm going to move these back up here so I have a little bit more room. And we'll talk about that idea is how do you move from one to the other? I'd like to move this down just a bit. There we go. All right, so here, how do I go from a 1/3 to a 12th? All right, how many twelfths would it take? Is 1/3 equal to how many twelfths? I want these to be equivalent sizes. So if I divide it into 12ths, how many do I need so it's the same size as if I had 1/3? Like I said, we're going to be using multiplication and division. So to go from the 3 to the 12, I multiply by 4. Okay. That means if you multiply by 4, you're going to multiply by 4. I'll put a times there to go from here to here. 1 times 4 is 4. So I have created two equivalent fractions. They represent the same amount, but the pieces themselves are different sizes. These little pieces that make up that are different sizes. This only took 1 and this one took 4, but they represent the same amount. These are called equivalent fractions. And I'm using multiplication. In Pearson, they're going to say you multiplied by the number 1. And you're thinking, how did I multiply by the number 1? Well, you could have, this right here, you multiplied by 4/4 in order to go from this fraction to this fraction. In order to, you want them to be equal, just they just look different. So you're multiplying by the number 1. Oops. So when we multiply, and we'll be doing that in this first section, you multiply straight across. 1 times 4 is 4. 3 times 4 is 12. So you multiplied by the number 1 to go from one fraction to its equivalent fraction, just different size pieces. Okay, this is the number. If you have 4 out of 4 pieces, you have a whole. If you have 3 out of 3 pieces or 5 out of 5 pieces. Well, let's discuss this right here and how to come up with this. Let's look at 1/3 to 2/6. All right, how do I go from here to here? If you're missing, they'll tell you the 6. We're missing this, we'll say. How do you go from here to here? Well, you multiply by the number 2, which means to go from here to here, you're going to multiply by the number 2. Whatever you do here because you're multiplying by 2/2, which is the number 1. So you multiply by 2, you get 6. You multiply by 2, you get 2. So 1/3 and 2/6 are called equivalent fractions. So we're multiplying by a certain number to go from one denominator to a different denominator. All right. Now, if you don't know what that number is, you can always use division to figure that out. 12 divided by 3 gives you 4. And division gives you a missing factor. Then you multiply those and you come up with 12. So we're going to be working on those ideas. We're also going to be working on the idea of how to go from 4/12 back down to 2/6, or 4/12 down to 1/3. Well, if you're multiplying to go in this direction, to go backwards, you're going to be dividing by a number. So if I have 4/12 and I wanted to go back to a third, I divide here, I divide by 4. So I will divide by 4. So division gets us back to smaller numbers. It's the same amount, it's just using smaller digits, which is what, when we're multiplying and dividing, we want our answer here. We use this process in adding and subtracting, is what we use this process for. This process is used for simplifying your answers. So that's kind of a quick overview, kind of give you a picture of what's happening. So let's go ahead and we're going to look at 3.4 to begin with. Okay. With 3.4, I'm going to leave those circles for a minute. We don't really need the picture of them. So I'm going to get this a little bit closer. All right, in 3.4, you're going to be multiplying fractions together. And when you multiply fractions together, the first thing you do is you look to see if you can reduce the fractions. Now, in this section, you're not going to be reducing the fractions. You're not going to need to do that, but we will in 3.6. It's just an added step, but it's not that hard. How do you multiply two fractions together? Well, to multiply two fractions together, those circles a little bit, I can move them out of the way. If you have a whole number, when you're multiplying fractions, put that whole number over 1. Okay. Now, normally we would say, okay, can we reduce? In other words, is there a number that would go into these or these evenly? So, but there's not in this section, so we'll kind of skip that. So once you have put the whole number over 1, you multiply straight across when we're multiplying fractions. So this gives us 84 over 5. And that's all the further you need to go. Don't change it to a mixed number right now. We're just going to leave it as a fraction. So my Pearson will say, you know, write your answer as a fraction. And this would be a fraction rather than a mixed number. Let's look at number 6, how to multiply a fraction times a whole number. So we take a negative 6/7 times 10 over 1. Go ahead and put your whole numbers over 1. And we'll multiply straight across. So you end up with, now we know that in multiplication, we have one negative. One is odd. So our negative stays. 6 times 10 is 60 over 7 times 1 is 7. So, you know, don't make this harder than it is. Let's look at number 7, just to, you know, make sure you guys have this idea. 8 over 1 times 2 over 3. Again, we put our whole number over 1 when we multiply. So then you multiply straight across here and here, 16 over 3. Okay, all right, and we'll be reducing later. But let's stick a variable in there and see what happens when you have a variable. So we have, again, parentheses means multiply. So we have a negative 3/11 times z over 1. I put the z over a 1, just like I put the 10 over the 1. I'm going to put the z over the 1. And I multiply straight across. Well, a negative times a positive, I've got one negative. So when I'm multiplying one negative times a positive, your answer will be negative. I'm going to put the answer down here. Negative 3 times z is a negative 3z. Negative 3z. When I multiply those together, then I take 11 times 1 and I get 11. And there's your answer. You're done. Let's look at number 9. Put your whole number over 1 times x over 5. You multiply straight across. After you put your whole number over 1, they mean the same thing. Then you come up with 4x. 4 times x is 4x. 1 times 5 is 5. Okay. All right. Now I hope that idea is understood. You know, if not, you're going to have to let me know. Well, let's do a few more that I have here. Just in case. They look a little different, but they'll be all right. In this case, the difference between these 6 and the ones we just did, except for number 16 is the same, is that rather than having a whole number, I have two fractions. When you have two fractions, you just don't have to put one of them over 1. Like here, you'll have to put the 7 over 1 to create two fractions. Here, you already have two fractions. So all you'll need to do is multiply straight across. If you don't like the parentheses, you can write it as a negative 11 over 8 times 1 over 5. That will work. And then you multiply straight across. This gives you a negative 11 Negative 11 times 1 is a negative 11. I knew it was going to be a negative because I only have one negative in my multiplying, and the number 1 is odd. Over 8 times 5 is, sorry about that, 8 times 5 is 40. Okay. So you end up with a negative 11 over 40. Let's try another one. Here, there's no parentheses. They already have the dot. And like I say, you could have just left it there and multiplied through it if you can't, if you want to, that's fine. Here, I've got two fractions that I'm multiplying together, and you could even have three fractions that you're multiplying together. You just multiply straight across, no matter how many you've got over, and then you multiply the denominators. But in this case, I'm going to take 3 times 7, 4 times 10. So I'm hoping this isn't too hard. All right, let's go ahead and look at number 14. Well, let's go ahead and do 13. I know it's negative because I have one negative. So then I take 7 times 1, 8 times 6. And there you go. Let's keep going. 14. You multiply straight across. 13 times 13 is 169. 15 times 15 is 225. You're done. Let's look at 15 because we've got some variables now. It's really not much more difficult. You multiply straight across. 3 times x is 3x. 16 times y is 16y. And there you're done. This one is like the previous page that we did. So here I would have it looks like a 9 a little bit. A over 5 times 7 over 1. And you multiply straight across. 7a, 7 times a is 7a. Notice we put the number in front of the variable. Over 5 times 1 is 5. Okay. All right. Well, I hope that kind of clears how to multiply fractions. It's not really too bad. But when we get to 3.6, we're gonna reduce them first before we multiply. But even that's not going to be that bad. Well, let's look at a story problem here. Griffin has several bookshelves. So we're going to apply this idea here. Applications of multiplying fractions. Griffin has several bookshelves in his apartment that he shares with a roommate. He has use of 5/8 of the shelves. If he has filled 1/3 of them with textbooks, what fraction of the shelves hold his textbooks? One key to remember in mathematics is that of means times, per means divide. So when you see the word of, chances are we're going to be doing some multiplication. There'll be some exceptions to that when we get into some percentages, but just kind of keep in mind that of is times and per means divide. Well, here we have he has filled 1/3 of the shelves. Well, that means he has filled 1/3 of 5/8, because that's the number of shelves he's got is 5/8. So he's filled 1/3 of what he's got. And so here you would multiply straight across, you get 5 over 24. Let's look at another story problem as a sample for your homework. All right, a chocolate espresso trifle is 11/3 inches high. If 2/5 of the trifle is a chocolate pudding layer, how many inches is the pudding layer? Well, the pudding layer is 2/5 of the trifle, which is this. Okay, so we're going to take 2/5 of the trifle, which is 11/3. And we'll multiply straight across. And we'll leave it as 22 over 15. Now this one right here, the units would be inches. And on the one before, it would be bookshelves. All righty. Okay, well, that pretty much does it for section 3.4. Let's look at section 3.5 next. 3.5 does kind of go back to our idea of the circles that we had. Okay. We're going to go back to this idea of going from one denominator to another denominator. So we're going to try to go from one, how do you go from 1/3? How do you go from a denominator of 3 equal pieces to 12 equal pieces, or a denominator from 6 equal pieces to 12 equal pieces? All right. And they're going to be giving you the denominators. You just need to know how many pieces with that denominator would be equivalent to this many pieces with that denominator, is what we're going to be doing here. All right, so let's say I have 3 8s. So I have something that's divided into 8s, and I have 3 of those pieces. I want the same amount, only now I want to divide it into 32 pieces. And I want these to be equivalent fractions, which means their value, their size is the same. Like our 1/3 was the same size as our 2 6, which was the same size as our 4 12ths. To do that, they say to multiply by 1. And the 1 that we're going to multiply by, to go from here to here, that's our key. What do you multiply by to go from 8 to 32? Well, if you're not real sure about your multiplication tables, you could take 32 divided by 8 on your calculator, and that'll tell you 4. So you take 8 times 4 and just check it. 8 times 4 on your calculator should give you 32. So division will tell you this number. Check it with multiplication. Division and multiplication work together. They're kind of back, they go back and forth with those two together. All right, so if I multiply by 4 here, I have to multiply by 4 here. It's like multiplying by the number 1, 4 over 4. So this is this 8 times 4 is 32. 3 times 4 is 12. So if I have 3 pieces of the 8s, I would have to have 12 of the 32nds in order for them to be equivalent. All right. So 12 32nds is the same as 3 8s. It's the same amount. Just that once these pieces are smaller, so I know I'm going to need more of them. These are smaller pieces. So I'll need more of those. Then I do the 8s. 8s are larger pieces, and I only needed 3 of them. Okay, let's look at this one. How do you go from here to here? Well, you multiply by 3. So that means to go from here to here, I multiply by 3. So I need, so 9 times 3 is 27. Now, if you don't know that 3, just take 27 divided by 9, and that'll tell you what to multiply by. Okay, now take 4 times 3, 12. All right, and get a 12 again. But anyways, if I were to had 9 pieces, 4 9ths, I would need 12 27ths to have the same amount. And again, these are smaller pieces, so I will need more of them. If you divide something into 27ths, the pieces are smaller. So I'll need more of them, but 4 9ths is equal to 12 27ths. They represent the same amount. Okay, let's go ahead and do this one. Now you have a negative, they have the negative. They put that in there for you. To go from here to here, I multiply by 4. So again, 20 divided by 5 is 4. To go in here, I'll multiply by 4. So I'm multiplying this fraction by the number 1. 4 over 4 is the number 1. That's what they mean by this here. So here, 7 times 4 is 28. So if you have a negative 7/5, okay, you have more than 1 actually here. You're going to have a negative 28/20. Okay. All right, let's keep working on this same idea. All right, here, to go from here to here, you multiply by 3x. That's what I multiply by, because 15 times 3 gives me the 45, but I also need an x over here. So I have to multiply by an x, so I end up with an x over here. So that means I'm going to multiply by 3x. 11 times 3x is 33x. All right, so these are equivalent fractions. Let's look at this right here. To go from here to here, I multiply by 2. Now, if you didn't know that, just take negative 26 divided by a negative 13, you're going to get 2. So I'm going to multiply by 2. I'll use a dot because look, we're doing variables. So you get 16. So 16, a negative 16/26 is the same as a negative 8/13. They're the same amount, just different size pieces, but the same amount. All right, the next one, we're going to take 192 divided by 24. Make sure I have that right. 8. So to go from here to here, I multiply by 8. So to go from here to here, I multiply by 8. I'm multiplying by 8 over 8, this fraction, 8 over 8. Negative 7 times 8 is a negative 56. You have one negative, you got to have a negative over there. All right, so now you're learning how to create equivalent fractions where the pieces are actually smaller than what you started with, but they're the same. And then eventually we're going to be going backwards, and then you're going to have to be dividing by the same number to make the pieces actually larger. Make these numbers smaller, but the pieces are increased in size. All right, now let's see. Let's look at the next, which is what we're going to do right now. So now I want to go backwards. So instead of having 4/12, I want to write the same fraction using smaller numbers, bigger pieces. So I want to be able to go from this. How do you go from 4/12 and make it look like 1/3? Or how do you go from 2/6 and make it look like 1/3? And both of these do need to go to the smaller number. That's our goal, is to get these down to where there's not a number that would go into either one of those evenly. All right, and again, we're going to use division. What do you divide by? That's going to be the issue. And that's why we can use our divisibility rules. What do you divide by? They're not going to give you the numerator that they want. They're not going to give you this and give you the 3. All right, they're not going to do that. You're going to have to know you're going to go from here to a 3. So how do you do that? Well, if you look at 9 and 12, you have to ask yourself, what's the largest number I could divide them by? So I want to divide them both by the same number. It's like dividing by 1. So we're simplifying. Well, 3 is the largest number that will go into both 9 and 12. That would be the number 3. So if I divide them both by 3, 9 divided by 3 is 3. 12 divided by 3 is 4. So if I had a whole that was divided into fourths and I had 3 of those, it would be the same size as if I had a whole circle divided into 12 equal parts and I took 9 of them. So in order to go backwards here, from here to here, we're dividing. But to go up here, we multiply. All right, let's look at number 12. Again, what could I divide? You do these separate. You can look at the 4 and the 8, and then look at your variables next. Well, here, what goes into 4 and 8 evenly? What's the largest number? Now, you could divide by 2. And if you divide by 2, you're going to have to ask yourself, am I done? Or could I divide by 2 again? Or you can just divide by 4 once. So let's go ahead and divide by 4. All right, and I'm writing this down. Some of you may be able to just cross it off, and 4 goes into 4 once, 4 goes into 8 twice. But for right now, I'll just write it like that. So we have 4 divided by 4 is 1. 8 divided by 4 is 2. So I'm reducing the fraction, I'm simplifying it. So I hope you see how we got 1/2. We'll be doing some more examples. So that's the 4 and the 8, 1/2. What about the x's? What happens with the x's here? Well, I know that if I have something like 3 out of 3, I have the number 1. Okay. If I have 4 out of 4, that's the number 1. So if I have x over x, they actually cancel and leave you with a 1. So they're gone. This means my answer is just 1/2. 1/2. Okay. The x's cancel each other out and leave you with just the number 1. And 1/2 times 1 is 1/2. All right, well, let's go ahead and let's look at this. What could I divide 22 and 36 by so that I can reduce the fraction? Well, let's see, I could let's divide them both by 2. And if I do that, the negative stays. I get 11 over 18. All right. I knew that 2 went into them because they're even. All right, their ones digit ended in a 0, 2, 4, 6, or 8. Then you can look at this and say, wow, am I done? Or is there a number that would also go into 11 and 18? And there's not, so you are done. There's your answer. Let's do another one. Let's say this one right here, 125 over a -5. What would go into both of those evenly? Well, the largest number that goes into both of those is actually 25. 25 goes into both of those numbers. But let's say you didn't realize that. So we're going to go ahead and I know they end in 5, so I'm going to divide them both by 5. So if I divide this one by 5 and I divide this one by 5, I get 25. Yep. Over -5. Because I have this negative here. It doesn't matter where you put the negative. So -25 divided by 5 is a -5. 125 divided by 5 is 25. Am I done? Well, they both end in 5, which means 5 goes into them. So I'm going to divide them again by 5. Here. 25 divided by 5, I'm going to have to put it down here as 5. -5 divided by 5 is a -1. So how do you write that? You can write that as a -5. -5. All right. You don't need it over the 1. It's not that it's wrong. It's just that this is better. All right. It's just better. So again, you're dividing by the same number. What can I divide both of these by in order to reduce it down so that we have smaller digits representing the same amount in that fraction? 13 and 39. Well, at first glance, you might think, wow, 13 is prime. Only 1 and 13 go into 13. So take 39 and divide it by 13. Take this and divide it by 13 and see if you do, if it is divisible by 13. It is. So I can divide them both by 13. So what that does is that leaves me with, here, I'm going to have to go over here, leaves me with a 1a. 13 divided by 13 is 1a. 39 divided by 13 is 3ab. I'm ignoring the variables right now. I'm just ignoring them and just paying attention to the numbers. What goes into both of those evenly? Now I'm going to look at the variables. So this is similar to 12. You see how those x's canceled on 12? Because they were the same, they canceled out. The a's also, so those a's will cancel out. But not the b. The b's got to stay. So my answer is 1 over 3b. All right. So I treated the numbers. I got the numbers. What goes into both of those numbers evenly? Okay. And a 13 gave me a 1. Divide that by 13, a 3. And then you look at the variables. and see what you can do. And we'll be looking at the variables more in chapter 10. Okay, let's look at 16. Well, both of them end in a 0, so I could divide them both by 0. An easy way, I can divide them both by 10. An easy way to do that when you divide by 10 is you can just cross off those. So this divided by 10 leaves you with 60. This divided by 10 leaves you with 75. All right, but I don't think we're done. Now our last digits are 0 and 5. Well, that tells us that 5 goes into both of those. So let's take a negative 60 divided by 5. So we're going to divide them both by 5 because they end in a 0 and a 5. So I know that 5 will go into them. So that leaves me with a negative 12. Negative 60 divided by 5 is a negative 12. 75 divided by 5 is 15. Let's see. Yep, 15. Good. All right. Am I done? Well, this adds up to 3, and this adds up to 6. So I know if these add up to 3, 3 goes into it. If these add up to 6, 3 goes into it. So I can divide them both by 3. So I get a negative 4 over 5. And finally done, negative 4/5. So you just keep dividing. And you have to divide by the same number in the numerator and the denominator. And that's it until you can't tell. The only thing that would go into both of those is the number 1. And then you're done. Awesome. That's reducing or simplifying. All right, now this next section is, how do you know if the fractions are equivalent? How can you tell just by given the 1/3 and the 2/6 that they represent the same size of the same amount? How would I know that 1/3 by looking at just the numbers is the same as 2/6? Sometimes they're equal and sometimes they're not. And how can I tell the difference? And we have a way of doing that. You could get the same denominator, but boy, that takes time. You know, changing a denominator, like changing that to a 15 and comparing. But an easier way is to cross multiply. That's one way. You take 2 times 15, you get 30. Does that equal, that's a question mark, does that equal 5 times 6? It does. So these are equal. So you can use this cross product idea. So it works. Let's look at another one. 1 times 23. Here, I'll just copy them over again. You know, sometimes I think it's kind of small, but 1/12. How does that, are they the same size? Are these two the same size? Well, we're going to cross multiply. We're going to take 1, this numerator times that denominator. 1 times 23. How does that compare to 12 times 2? This is 23. This is 24. They're not the same. These fractions do not represent the same amount. All right. Let's look at another one. Again, I'll use a separate sheet of paper here. Straighten it out. There. Okay, here we have 13/3 negative, and we have 17/4. Are these the negative 17/4? And what I'll do is I'll just put the negative with the numerators, just make them match. So I'm going to take this times this. All right, so I'm going to take a negative 13 times 4. Does it equal 3 times a negative 17? This right here is a negative 52. Okay. This right here, when I multiply these, I get a negative 51. So these are not equal. Those fractions do not represent the same amount. They just don't. And that's the symbol we use for not equal. Equal with a slash on it. And that should show up at the bottom of Pearson when you're typing that in, it should show up. Let's just do maybe one more because I think you've probably got this idea. So let's go ahead and look at number 20. Okay, so we're going to take 2 8ths and 8 32nds and see if these fractions represent the same amount. So we're going to cross multiply. 2 times 32. Does that equal 8 times 8? Okay, this gives you 64 when you multiply 64. So they are equal. They represent the same, they're equivalent. That's the word we use. When these fractions are equal, we say they're equivalent fractions. They represent the same amount. Okay, wow, that's great. That does 3.5. So now we're going to look at 3.6. I think 3.6 won't be too bad. 3.6 is just a matter of multiplying fractions, but we're going to have an extra step. We're going to reduce before we multiply. So what I'm going to do is I'm going to copy these over as I go through them so that I have more room. So we'll start with 3/4 times 1/3. Now in 3.4, I just multiplied across and I was done. But we're going to reduce these. And reducing these is the same as we did in 3.5. You can reduce anything in the numerator with anything in the denominator. Could I divide those numbers by the same thing? Any of those numbers by the same thing? Well, here I can divide this by 3 and this by 3. This is like the x over x. They canceled. So 3 goes into 3 once. 3 goes into 3 once. Now when I multiply, now you're done. The 4 stays, it will not reduce out. So then you multiply straight across. 1 times 1 is 1. 4 times 1 is 4. So we're just going to reduce these by dividing the numbers by the same amount, if possible. And boy, these aren't really bad at all. Let's look at 6. All right. So I have 5/9 times 9/14. Okay, the 9s, they're going to cancel out because 9 divided by 9 is 1. 9 divided by 9 is 1. So I'm dividing the numerator and denominator by the same number, 9, dividing them both by 9. Now nothing goes into 5 and 14. So it's done. We're reduced as far as we can and we multiply straight across. 5 over 14. 5 times 1 is 5, 1 times 1. All right. Okay. Let's look at the next one here and see what we've got. Here, -1. -1 over 9 times 6 over 11. All right, let's go ahead and we want to reduce. So is there a number that I could divide into either of these that would also go into either of those, both? Well, let's see. I could divide this by 3 and this by 3. All right, because 3 goes into 6 and 3 goes into 9. So let's do that. Let's divide this by 3 and I get 2. And let's divide this by 3 and I get 3. Okay, dividing by 3 over 3. So I've got a 1 and a 2 in the numerator and a 3 and 11. There's nothing that will go into these two that would also go into these two, or one or the other. So we're done. So we multiply across. -2, because I have a negative times a positive is a negative, over 33. So that's the reduced fraction. Okay. Let's do another one. This might be, I'll have to look at the other side. I can't really remember any other topics, but this might be it. So we have 2x over 5 times 15 over 8. Is there a number that would go into either of those and would also go into either of these? Well, let's look at the 2 and the 8. 2 goes into 2 and 2 goes into 8. So let's go ahead and do that. 2 goes into 2 once. 2 goes into 2 goes into 8 4 times. I divided them both by 2, and that's what I ended up with. 8 divided by 2 is 4. 2 divided by 2 is 1. Now, if you look at the 5 and the 15, I can reduce the 5 and the 15. Now, again, I'm reducing anything up here with anything down here. I can't reduce side to side. I have to go top to bottom. Well, 5 goes into both of those numbers because they end in 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So I've got a 1 and a 3 and a 1 and a 4. Looks like I'm done reducing. Don't forget about that x. So I'm going to take 1x times 3, and I get 3x. 1 times 3 is 3, and then you have the x over 1 times 4. So 3 times x over 4 is your answer. All righty. Let's look at number 9. We have a -7, so we know we put our whole numbers over 1 times 1 over 7. And again, I can reduce anything here with anything here. I know that 7 goes into 7 and 7 goes into 7. So let's divide both of those by 7. This divided by 7, we have a 1. We still have the -1. This divided by 7 is 1. So when I do multiply across, I get a -1 multiplying across. 1 times 1 is 1. This is equal to a -1. So I put my whole numbers over 1, I reduce, and I multiply across. Let's try number 10. Just going to turn this over here. Now, turn it over. We have a -4/3 parentheses like this means multiply. First off, decide, is your answer going to be negative or positive? Let me. Is your answer going to be negative or positive? Well, you have 2 negatives, which means your answer is positive. Because if you have an even number of negatives, your answer is positive. So here, we know our answer is going to be positive, but let's reduce it. Either of those reduce with either of these? Well, 4 goes into 4 once. 4 goes into 4 once. 3 goes into 3 once. 3 goes into 3 once. I know it's going to be a positive. 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is 1. All right, so you reduce and multiply. Okay, let me see if there's any of these others that might give you guys some issues here. Let's see, we can try number 13. Okay, let's try number 13. We have 7 over 8y times a -9 over 14. Now I do know my answer is going to be negative because of that negative. I've got 1 negative and 1 is odd, so the answer is negative. So as you're reducing, you can kind of ignore it. You've already decided where it's going to go. Okay, anything here reduce with anything here. Well, The 7 and the 14. Okay, those will reduce because 7 goes into here once, 7 goes into here twice. So I'm dividing the numerator and denominator by 7 over 7, dividing by 7, dividing by 7. That's it, because there's nothing that goes into 9 that would also go into 8, and there's nothing that goes into 9 that would also go into 2, because we can only go from here to here. We can't go across this way to reduce. So we multiply 1 times 9, 9, we already got our negative. 8y times 2 is 16y. And then you're done. All right, so I'm hoping that that's not too difficult of an idea. The other ones, let's see. Let's look at some more with some variables, just in case the variables kind of give you guys some issues here. So let's look at a few more with some variables, same idea. I'm going to copy this down. I want a clean sheet of paper. Here, focus it again. All right, I've got 9b over 8 times 16 over 27b. Now, anything in the numerator can reduce with anything in the denominator. Anything here can reduce with anything here. Well, let's look at the 16 and the 8. All right, I know that 8 goes into both of those. So I'm going to divide them both by 8. So divide this by 8, I get a 2. Divide this by 8, I get a 1. Okay, so far so good. Now let's look at the 9 and the 27. 9 goes into 9 once. 9 goes into 27. How do I know 9 goes into 27? Well, 2 plus 7 is 9. So 9 goes into that, so it'll go into here. 27 divided by 9 is 3. Now we have some variables. Do they cancel out or are they going to stay? Well, because they're equal, okay, they will cancel each other out here. So you end up with 1 times 2 is 2. 1 times 3 is 3. So you end up with 2/3. Let's look at 16 because it also has some variables, just in case. Because, you know, if you understand, you can always you don't have to watch the video anymore. But in case you want a few more practice, let's do that. I have 11 over 5n times 10m over 7. What about this one? Well, let's reduce anything here. Is there something that goes into those that would also go into these? Because reducing, you divide. 10. Let's see, 10 and 5 will reduce because 5 goes into both of those. 5 goes into there twice. 5 goes into there once. This is how you reduce. You divide by the same number. That's it, because nothing will go into like the 11 and the 7 other than 1, and the 2 and the 7 they don't reduce. What about the variables? I've got an m and I have an n. They're different, so they're not going to cancel. They're going to stay. So when I multiply across, I multiply the numbers that are left, the 11 and the 2. I multiply those, and I still have times m. And then here in the denominator, 1 times 7 is 7, n times n. And that's as far as you can reduce it. So I'm hoping that you understand how to reduce a fraction and the fact that you do reduce before you multiply. If you reduce before you multiply, you will never have to reduce after you multiply. And it's a lot easier to reduce here than it is when you created larger numbers over here. And then to reduce, you just find a number that you can divide the number, both either these by, like divide them both by 5 and 5, something in common that you can divide them both by, the numerator and the denominator. All right. Well, I think that's pretty good for now. I hope that all of this kind of made sense. I really encourage you to let me know if you need some extra help, because I would love to help you by meeting you on Zoom or meeting you in the Math Center. So just let me know. Okay, take care, and that's all. Let me see if I can stop this. Stop the recording.